Water pollution. The great solvent power of water makes the creation of absolutely pure water a theoretical rather than a practical goal. Even the highest quality distilled water contains dissolved gases and to a slight degree, solids. The problem, therefore, is one of determining what quality of water is needed to meet a given purpose and then finding practical means of achieving that quality. The problem is further compounded because every use to which water is put, washing, irrigation, flushing away wastes, cooling, making paper, etc., adds some to the water. In fact, for centuries rivers and lakes have been used as dumping grounds for human sewage and industrial wastes of every conceivable kind. Many of them are highly toxic. Added to this are the materials leached and transported from land by water percolating through the soil and running off its surface to aquatic ecosystems. The term water pollution is referred to any type of aquatic contamination between following two extremes. 1. A highly enriched, overproductive biotic community, such as a river or lake with nutrients from sewage or fertilizer cultural eutrophication, or 2. A body of water poisoned by toxic chemicals which eliminate living organisms or even exclude all forms of life. See Southwick, 1976. Normally water contains two types of impurities: dissolved and suspended. Dissolved impurities are gases H, S, Colorado, NH, etc. and minerals Ca, Mg, Na, salts. Suspended matter includes clay, silt and sand and even microbes. Polluted waters are turbid, unpleasant, foul-smelling, unfit for drinking, bathing and washing or other purposes. They are harmful and means of many diseases as cholera, dysentery, typhoid, hepatitis, etc. E1LRRY-RKE2. Types of water pollution. Types of water pollution may be classified by the medium in which they occur, such as surface water pollution, groundwater pollution, soil water pollution, etc., the habitat in which they occur, such as river pollution, lake pollution, estuarine pollution, coastal water pollution, open ocean pollution, etc., and source or type of contamination, such as nutrient pollution, bacterial pollution, viral pollution, metallic pollution, petrochemical pollution, pesticide pollution, thermal pollution, radioactive pollution, etc. Kinds and sources of water pollutants. Pollutants entering water sources are classified broadly into following categories: domestic sewage and oxygen-demanding wastes, infectious agents, plant nutrients, chemicals such as insecticides, herbicides, and detergents, other minerals and chemicals, sediment from land erosions, radioactive substances, and heat from power and industrial plants. These aquatic pollutants come from many sources. Excessive nutrients, such as nitrates and phosphates, commonly originate in domestic sewage, runoff from agricultural fertilizer, waste materials from animal feedlots, packing plants, etc. Toxic chemicals as agents of water pollution originate in industrial operations, acid mine drainage, surface erosion from strip mines, washing of herbicides and insecticides, radioactive fallout from atomic explosion, and commercial accidents such as soil spills or rupture of chemical tanks. Besides the pollutants which come from point sources such as sewage, factory or industry, there are many pollutants which come from watershed runoff. Urban and suburban runoff, for example, contains many pollutants such as oil, pesticides, radioactive dust, salt, fertilizers, miscellaneous chemicals, and nematodes, pathogenic protozoans, bacteria and viruses. However, Kimball 1975 recognized only three major sources of pollution: domestic, industrial and agricultural. Ecology of water pollution. Each type of water pollution affects the abiotic and biotic factors of different aquatic systems in different degrees, and its ultimate effect on man remains quite drastic in medical, aesthetic, and economical sense. Some of the well-known ecological effects of water pollution are following. 1. Sewage pollution. Contamination of freshwaters and shallow offshore seas by sewage is a common occurrence. Domestic sewage and wastewater is about 99.9% water and 0.02-0.04% solids, of which proteins and carbohydrates each comprise 40 to 50% and fats 5 to 10%. Simmons, 1974. In other words, sewage includes mostly biodegradable pollutants such as human fecal matter, animal wastes, and certain dissolved organic compounds, e.g., carbohydrates, urea, etc., and inorganic salts such as nitrates and phosphates of detergents and sodium, potassium, calcium, and chloride ions. Under natural processes, most of the biodegradable pollutants of sewage are rapidly decomposed, but when they accumulate in large quantities, they create problem, i.e., when their input into environment exceeds the decomposition or dispersal capacity of the latter. Most cities of well-developed countries such as USA, Britain, etc., and some cities of developing countries such as India have evolved certain engineering systems, such as septic tanks, oxidation ponds, filter beds, wastewater treatment plants, and municipal sewage treatment plants for the removal of many harmful bacteria and other microbes, organic wastes, and other pollutants from the sewage before it is tipped into river or sea. Sewage treatment is usually performed in following three stages. 1. Primary treatment, which removes large objects and suspended undissolved solids of raw sewage and converts them into a biologically inactive and aesthetically inoffensive state, the sludge, a valuable fertilizer. 2. Secondary treatment, which supplies aeration and bacteriological action to decompose organic compounds into harmless substances such as CO, sulfate, and water. During later stages of secondary treatment, whole wastewater is chlorinated, i.e., treated with chlorine to reduce its content of bacteria. 3. Tertiary treatment, which removes nitrates and phosphates and releases pure water. These three stages of sewage treatment have become increasingly expensive, and only in most advanced countries all the three treatments of sewage are done. However, most Indian cities either lack any sewage or wastewater treatment plant or have inadequate sewage treatment facilities. Consequently, normally and especially during heavy downpour and floods, raw sewage or incompletely treated sewage is dumped into rivers, which cause severe water pollution problems in following ways. Bacterial and viral contamination. Sewage wastes may contain pathogenic bacteria and viruses which are a threat to human health. Waterborne diseases such as typhoid, bacillary dysentery, amoebic dysentery, botulism, poliomyelitis, and hepatitis all represent potential health hazards in sewage-contaminated waters. Due to such kinds of sewage pollution, waters of many ponds, lakes, rivers, sea beaches in India and abroad have been prohibited for human use, whether for drinking, bathing, swimming, or other sort of water recreation. BOD test. BOD, or biological oxygen demand, is the amount of oxygen required for biological oxidation by microbes in any unit volume of water. The test is done at 20 degrees Celsius for at least 5 days. BOD value generally approximates the amount of oxidizable organic matter, such as sewage and other organic wastes, animals and human excreta, all of which are called oxygen-demanding wastes, and is, therefore, used as a measure of degree of water pollution and waste level. Thus, due to addition of sewage and waste, oxygen levels are depleted, which are reflected in terms of BOD values of water. The number of microbes as Escherichia coli bacterium also increased tremendously, and these also consume most of the oxygen. The number of microbes as Escherichia coli bacterium also increased tremendously, and these also consume most of the oxygen. The number of bacteria as E. coli in unit volume of water is also taken, called E. coli index, as a parameter of water pollution. The quantity of oxygen in water, called dissolved oxygen or DO, along with BOD, is indicated by the kind of organism present in water. For example, fish become rare at DO value of 4 to 5 ppm of water. Further decrease in DO value may lead to increase in anaerobic bacteria. Typical BOD value for raw sewage run from 200 to 400 milligrams of oxygen per liter of water, therefore, 200 to 400 ppm. Water for drinking should have a BOD less than 1. E. Eutrophication. According to Hutchinson, 1969, the eutrophication is a natural process which literally means well-nourished or enriched. It is a natural state in many lakes and ponds which have a rich supply of nutrients. And it also occurs as part of the aging process in lakes, as nutrients accumulate through natural succession. Eutrophication becomes excessive, however, when abnormally high amounts of nutrients from sewage, fertilizer, animal wastes, and detergents enter streams and lakes, causing excessive growth or bloom of microorganisms and aquatic vegetation. Most secondary sewage treatment plants, though, precipitate solids and inactivate nitrates stimulate algae growing in water as well as plants growing in moss bocce tne do army strata ic sewage, soil. If runoff from fertilizer gets into a body of water, algae grow so, yet they do not remove the basic profusely that they form a blanket over the surface. This usually nutrients such as ammonia happens in summer when the light levels and warm temperatures. Nitrogen, nitrates, nitrites and favor growth. Phosphates. These nutrients stimulate algal growth and lead to plankton blooms. Some plankton blooms, particularly those of blue-green algae, produce obnoxious odors and tastes in waters. Others, such as the dinoflagellate blooms or the red tide of southern coastal regions, produce toxic metabolic products which can result in major fish kills. Plankton blooms of green algae do not always produce undesirable odors or toxic products, but still create problems of oxygen supply in the water. While these blooms exist under abundant sunlight, they contribute oxygen to the water through photosynthesis, but under conditions of prolonged cloudiness, they begin to decay and consume more oxygen, and with heavy load the oxygen contents of the water may diminish below the point where most fish cannot survive. As the conditions in the water become anaerobic due to increased oxygen depletion by bacterial decomposition or planktonic blooms, the breakdown products become reduced rather than oxidized molecules, many of which, e.g., hydrogen sulfide, produce offensive odors and tastes. Excessive nutrient levels in aquatic systems can also cause two other kinds of ecological problems. Primarily, they may lead to extensive growth of aquatic weeds such as Eurasian milfoil, water hyacinth, water chestnut, etc. Excessive growth of these weeds can impair fishing, class 1, bathing, fish spawning, shell organisms, fish production, and even navigation. Sculthorpe, 1967. Secondarily, nitrates can be converted in the human digestive tract by certain bacteria to nitrites, and the same transition may occur in open cans of food. Even if they are subsequently refrigerated, nitrites react with hemoglobin, forming methemoglobin which will muscle not take up oxygen. Pike. Labored breathing in class 1. Occasional suffocation result organisms shrimp you. Most severely in human. Damselfly larva, caddisfly larva, mayfly larva, stonefly larvas. And percent water penny whirligig beetle 3 didiscus. Dragonfly. Infants. Nitrites may also large planaria react with creatinine present in the vertebrate muscles. Mosquito to form nitrosarcosine pulmonate larva. Leech which can be carcinogenic. Snail. C. Simmons, 1974. Classy Southwick, 1976. Organisms. Effects of organic TEL. Pollution on aquatic chironomid rat-tailed animal life. Organic polylarva maggot tube effects. Tion tends to bring about changes in faunal compo. See Figure 14.14. Classes of stream fauna used as pollution indicators. Tion in a freshwater ecosystem. Nymphs of stoneflies and mayflies are the first to disappear from water which has high organic pollution. As pollution increases, caddisfly larvae and many fish which require high levels of environmental oxygen move into less polluted area of the stream. Shrimps, water fleas, leeches, snails and most of the fish vanish as the pollution becomes severe. At such levels of pollution there is very little of dissolved oxygen and the animals present are chironomid larvae, bloodworms, and the oligochaete worms. Tube effects. Figure 14.14. Some decomposing plants are known to produce toxins as strychnine which kills animals including cattle. 2. Industrial pollution. Most of the Indian rivers and freshwater streams are seriously polluted by industrial waste of effluents. See Table 14-3. Effluents are waste products in a liquid form resulting from industrial processes and domestic activities. They are released by different industries such as petrochemical complexes, fertilizer factories, oil refineries, pulp, paper, textile, sugar and steel mills, tanneries, distilleries, coal washeries, synthetic material plants for drugs, fibers, rubber, plastics, etc. The industrial wastes of these industries and mills include metals, copper, zinc, lead, mercury, etc., detergents, petroleum, acids, alkalis, phenols, carbamates, alcohols, cyanide, REI, L-G-senic, chlorine and many other inorganic and organic toxins AgE-cants. All of these chemicals of industrial waste are toxic to I_I_ animals and many cause death or sublethal pathology of the equals, IT liver, kidneys, reproductive systems, respiratory systems, or nervous systems in both invertebrate and vertebrate. Aquatic animals. Wilbur, 1969. Chlorine which is added to water to control growth of algae and bacteria in the cooling system of power station, may persist in streams to cause mortality of plankton and fish. Heavy fish mortality in river. Sown near dairy on sown in Bihar is reported to cause by free chlorine content of the chemical wastes discharged by Figure 14.15. Minamata disease caused by factories near Mirzapur in UP. Mercury pollution. Mercury, like other heavy metals such as lead and cadmium, has cropped up as a toxic agent of serious nature. Mercury, a byproduct of the production of vinyl chloride, is used in many chemical industries and it is also a byproduct of some incinerators, power plants, laboratories and even hospitals. Aronson, 1971. In Japan, illness and even death occurred in the 1950s among fishermen who ingested fish, crabs, and shellfish contaminated with methyl mercury from Japanese coastal industries. This mercury poisoning produced a crippling and often fatal disease called Minamata disease, Fig.14.15. Initial symptoms of Minamata disease included numbness of the limbs, lips, and tongue, impairment of motor control, deafness, and blurring of vision. Cellular degeneration occurred in the cerebellum, midbrain, and cerebral cortex, and this led to spasticity, rigidity, stupor, and coma. In Japan in 1953, due to Minamata disease 17 persons died and 23 became permanently disabled. See Southwick, 1976. Quit recently. Dash and co-workers 1988 studied mercury pollution due to effluents of a paper mill in the river Ibe of the Mahanadi water system in Orissa. The paper mill uses mercury as a cathode in chloroalkali electrostatic cells, and mercury leakage can be as high as 200 milligrams ton of chlorine produced. Ferguson, 1982. Analysis of mercury in some fish showed 500 times biomagnification or bioamplification over the downstream surface water. Generally, benthic fish and those higher in the food chain accumulated more mercury. People of the villages of that region, who used river water for drinking, suffered from diseases of eye, skin rashes, and anemia. 3. Thermal pollution. Various industrial processes may utilize water for cooling, and resultant warmed water has often been discharged into streams or lakes. Coal or oil-fired generators and atomic energy plants cause into large amount of waste heat which is carried away as hot water and cause thermal pollution or calefaction warming. Thermal pollution produces distinct charges in aquatic biota. A body of water at 30-35 degrees Celsius is essentially a biological desert, and many game fish require temperatures of 10 degrees Celsius for successful reproduction, although they will survive above that temperature. A temperature rise of 10 degrees Celsius will double the rate of many chemical reactions, and so the decay of the organic matter, the rusting of iron, and the solution rate of salts are also accelerated by calefaction. Since the rate of exchange of salts in organisms increase, any toxin is liable to exert greater effects, and temperature fluctuations are likely to. Thermal pollution. Up organisms. Some plants and animals are killed out right by the very hot water. Other adverse effects of aquatic pollution on aquatic life include I. Early hatching of fish eggs, E. Failure of trout eggs to hatch, E. Failure of salmon to spawn, IV. Increase in VOD, i.e. solubility of oxygen is reduced causing deoxygenation, V. Change in diurnal and seasonal behavior and metabolic responses of organisms, V. Significant shift in algal forms and other organisms towards more heat-tolerant forms. This leads to decrease in species diversity, V. Affect changes in macrophytes, and V. Migration of some aquatic forms. 4. Silt pollution. A result of intensive agriculture, earth moving for construction projects, poor conservation practices, and downpour with resultant floods, is the increased production of silt in streams and lakes. This load of particulate matter cuts down primary productivity by decreasing the depth of light penetration. Silt may also interrupt or prevent the reproduction of fish by smothering eggs laid on the bottom. 5. Water pollution by agrochemicals. Water that flows on the surface of crop fields, where agrochemicals such as fertilizers, pesticides, and herbicides are used, contributes to heavy water and soil pollution. Pesticides and weedicides are used by human beings to control crop diseases by the pests or to kill the weeds and, hence, to increase the productivity. The use of these toxic chemicals has created health hazards not only for livestock and wildlife but also for fish, other, aquatic organisms, birds, and mammals including man. Apart from killing the living organisms present on the surface of the soil, they reach even the deeper layers through tilling and irrigation of the land, killing still more living forms which might be involved in soil formation or humus formation, e.g., earthworms, centipede, millipede, etc. With their continuous use, the soil microorganisms lose their ability of nitrogen fixation. Moreover, when these chemicals find their way into water supplies, they contaminate and disrupt the aquatic ecosystem as well. Any substance or mixture of substances which prevents, repels, destroys, or mitigates any pest, e.g., bacteria, viruses, fungus, insects, nematodes, rodents, etc., is called a pesticide. Pesticides have proved tremendously beneficial to human populations in reducing or eliminating the target organisms such as insects, snails, rats, and other animals which transmit disease, destroy agricultural crops, damage homes and stored products, and directly or indirectly affect human health and welfare. Hence, the significance of chemical pesticides controlling mosquitoes, termites, houseflies, cockroaches, house crickets, weevils, locusts and grasshoppers, borers, snails, rats, rabbits, and multitudes of other animals has been great, and it is difficult to imagine modern disease control in agricultural programs without some forms of chemical control. Like pesticides, herbicides are specifically designed chemicals for the control of weed pests and unwanted plant growth. Table 14-3. Some Indian rivers and their major sources of pollution. Two. Jamuna near the but these pesticides have created their targets are in the pesticides have been in the food chain. In the first place, 15. Soao in Balrampur, sugar industry. Ecologically, pesticides and herbicides have created two major serious problems which were not previously anticipated. In the first place, many of them have persisted and accumulated in the environment and have harmed or contaminated numerous animals or plants not intended to be targets. Secondly, many of them have directly or indirectly affected human health. Biomagnification or bioamplification. Many of pesticides, such as DDT, aldrin and dieldrin, have a long lifetime in the environment. They are fat-soluble and generally not biodegradable. They get incorporated into the food chain and ultimately deposited in the fatty tissues of animals and man. In the food chain, because of their buildup, they get magnified in the higher trophic levels called biological magnification or biological amplification. The pesticides have been in use during last 50 years. Their targets are insect pests, fungi, nematodes and rodents which damage crops. But these pesticides have created great problems for non-target organisms consisting largely beneficial species such as earthworms, honeybees, fish, amphibia, some reptiles, birds, mammals and man. The phenomenon of biological magnification is also reported for certain other pollutants such as heavy metals such as lead, mercury and copper and radioactive substances or radionuclides as strontium-90. Toxicity of pesticides. The toxicity of organochlorine pesticides, i.e., DDT or dichlorodiphenyltrichloroethane, hexachlorocyclohexane, chlordane, aldrin, dieldrin, etc., lies in their inhibiting Na+, K+ and Mg+ adenosine triphosphatase activity in the nerve endings of animals, particularly insects. It affects the sensory, motor nerve fibers in the motor cortex. Matsuma and Pottle, 1961. In the giant axons of cockroach, DDT is known to influence the efflux of potassium ions from the axon. DDT and other organochlorine pesticides are absorbed from the intestinal tract, from the alveoli of lungs, and also through the skin. If the pesticides are in solution, a high concentration of DDT causes brain lies in their inhibiting Na+, K+ and Mg+ adenosine triphosphatase activity in the nerve endings of animals, particularly insects. It affects the sensory, motor nerve fibers in the motor cortex. Matsuma and Pottle, 1961. In the giant axons of cockroach, DDT is known to influence the efflux of potassium ions from the axon. DDT and other organochlorine pesticides are absorbed from the intestinal tract, from the alveoli of lungs, and also through the skin. If the pesticides are in solution, a high concentration of DDT causes brain damage, central lobular necrosis of the liver, and liver enlargement in small mammals. Concentration as low as 5 to 10 ppm in diet cause liver damage. In some birds, DDT concentration of 1 to 3 ppm destroys the female sex hormone, and the eggshell becomes so thin that the eggs break when the parents sit on them for hatching. Organophosphorus insecticides are absorbed by the gastrointestinal and respiratory tracts and the skin. These insecticides inhibit the acetylcholinesterase (ACE) enzyme. Thus, an abnormal accumulation of endogenous acetylcholine occurs. This causes excessive activity of the parasympathetic system, in the form of sweating, abdominal cramp, chest discomfort, vomiting, overactivity of smooth muscles, and so on. It also causes headache, nervousness, and overactivity of voluntary muscles. The nervous system is also adversely affected. The carbamate insecticides are absorbed by all portals, including the skin. These pesticides are reversible inhibitors of ACE. 6. Marine pollution. The marine ecosystem, i.e., seas, oceans, and estuaries, is so grand and vast but interacting in various ways with human life. How mighty and majestic ocean may appear to us, it was once challenged and tamed by Lord Rama during his march towards Ravana's Lanka. The oceans are used for navigation, fisheries, aquaculture, mining, acquisition of water, naval and military exercises, as well as for the discharge and dumping of a variety of wastes. The very vastness of the ocean has led to the assumption that all wastes dumped into them can be harmlessly absorbed. Such an assumption now belongs to the past. The ever-increasing range and volume of polluting activities intend to seriously affect marine production. Marine pollution is most evident in coastal waters and estuarine areas. The oceans have in fact become the final settling basin for millions of tons of waste products from human activities. For example, in the late 1960s, West Germany was dumping 375 tons of sulfuric acid, 750 tons of iron sulfate, 20 tons of chlorinated hydrocarbons, and 16,000 tons of gypsum wastes into the North Sea and North Atlantic Ocean every day. Table 14-4 shows a few of the industrial and agricultural pollutants reaching the ocean annually in the mid-1970s. Thus, petroleum and its distillates, halogenated hydrocarbons including pesticides, organic compounds including detergents, domestic raw sewage, agricultural runoffs, inorganic chemicals including metals such as mercury, lead and copper, dumped containers, radioactive wastes, cooling waters from industries and hydel projects and coastal constructions are the major pollutants entering the sea. Often the noxious pollutants are not dispersed and diluted but tend to remain concentrated and localized, or when diluted may be reconcentrated by living organisms. This tremendous burden of pollutants is evidently affecting the health and integrity of the world's oceans. Due to oceanic pollution, the marine biota has been seriously affected. Cousteau, 1974, reported a 30 to 40% decline in the overall productivity of pelagic organisms from shrimps to whales in the past 25 years. He also observed a serious shrinkage of coral reefs in many tropical areas of the world, and a displacement of these rich and varied communities with turbid and relatively barren waters. There has occurred a decline in populations of many fishes due to oceanic pollution. Oil spills have killed water birds, mammals, fish and vegetation. Hunt, 1965. Oil is the most apparent pollutant of the ocean. It discharged into the sea either deliberately when oil tankers are washed out prior to reloading or in accidental spills when tankers are wrecked during war or otherwise. In coastal areas when oil spreads on the water surface, it clogs the feathers of diving birds making their flight impossible. White preening themselves in an attempt to clear the plumage, they swallow enough oil to poison themselves. Apart from these, oil interferes with the insulation provided by the feathers and the birds die of cold or become susceptible to pneumonia. When oil covers the rocks and seaweeds, mollusks and crustaceans growing on them die. Oil spills on the coasts of seaside resorts drive away holidaymakers, affecting the economy of the place. Examples of industrial and agricultural pollutants discharged annually in control of water pollution. Most cities of the world have evolved certain engineering systems such as septic tanks, oxidation ponds, filter beds, wastewater treatment plants and municipal sewage treatment plants for the removal of various pollutants from the sewage before it is stripped into river or sea. It is essential to have modern sewage treatment plants for every town and city of India so that the biodegradable as well as non-biodegradable pollutants can be removed from it and pure water obtained for recirculation. The urban sewerage condition of India is quite distressing. At present only 15 Class 1 cities out of 142 are fully sewered, whereas only 7 of the 190 Class 2 towns claim to have this facility. Still the Indian cities continue to pour their waste water 286,000 million cubic meter into natural water sources. Currently, water hyacinth, Eichhornia crassipes, and otherwise pernicious aquatic weed has come into prominence for purifying domestic and industrial wastewater. The plant regenerates rapidly and has a tremendous capacity to accumulate heavy and even radioactive metals. It is efficient in absorbing nitrogen, phosphorus and similar chemical pollutants. The polluted water fed into reservoirs or lagoons with water hyacinth. Water hyacinth plays an important role in controlling, becomes markedly clean and free from 75 to 90%. Water pollution. Scent of its pollutants. This plant has also been used as a new source of food, fertilizer and biogas energy. In India, the enactment of Prevention and Control of Water Pollution Act in 1974 has helped to a certain extent to prevent water pollution. However, adequate legislative measures have to be adopted by every state to ensure a proper disposal of sewage and industrial wastes, b. prevention of abuse of water resources, c. recycling of wastewaters through proper methods of purifications, and d. punishment of erring industries which do not install effluent devices in their factories. A large number of international and intergovernmental agencies are now busy in controlling marine pollution. A number of highly hazardous pollutants are blacklisted and their discharge in the sea is totally prohibited. These are halogenated organic compounds, tin, mercury and cadmium compounds, radioactive isotopes and carcinogenic material. Somewhat less toxic substances are gray-listed such as compounds of arsenic, zinc, and antimony, cyanides, organosilicon compounds, crude oils, foam-forming detergents and surfactants, see Ambushed, 1990. Realizing the devastation caused by the population of cities, towns and villages of 8 states and the Union Territory located along the coasts of River Ganga, through its run of 2,525 kilometers from Gangotri Himalayas to Ganga Sagar Bay of Bengal, the government of India has launched Ganga Action Plan to restore its water quality. The first phase of this clarifier gigantic cleaning operation polluted L. had been initiated in year equals water OI. 1985 and may take several HI. 1. U. years in its completion. LFEN rotating. O. Mixing biological. Tank contactors sand filter. The wastewater polluted with cyanides and heavy metals can be purified by certain bacteria which cannot only withstand but are also able to grow at high level of cyanides. Millions of these bacteria are introduced in each of the several rotating discs of the plant's main processing units, figure 14.16. The stickly body surfaces of these bacteria pick up zinc, iron and other metals from the industrial wastewater as it passes over the plates. These bacteria also absorb cyanide so toxic to the fish and other aquatic life. Subsequently this water is passed through clarifier, and filtered and then released into the streams. In the past, attempts have been made to get rid of oil slicks by spraying them with detergents which break up the oil into drops. The trouble is that detergents are even more deadly than the oil and they kill many marine organisms that might have escaped the oil. Nowadays less destructive methods are used. Recently, a product, brake oil, resembling sawdust from paper industry waste has been employed. It rapidly absorbs oil. The resulting residue can be conveniently handled and even burnt as a fuel. Bacteria which thrive on oil eventually break it down and this brings about a regeneration of fauna and flora even within a year. Recently a strain of the bacterium Pseudomonas petita has been created by genetic engineering which breaks down octane, xylene and camphor C. Green et al. 1990. 3. IAND pollutants and IAND-POLLUTION. The land pollution is caused by solid wastes and chemicals. There are many examples of land that has been stripped of vegetation by industrial development and disposal of waste. Some common soil contaminants, their sources and wide-range impacts on the biota have been summarized as follows. The slag heaps from mines bear witness to the destructive effects which this can have on our environment. Areas around smelting and mining complexes are usually soiled by metals such as cadmium, zinc, lead, copper, arsenic and nickel. These are not only phytotoxic even in small amounts but also render plants unsafe for human and animal consumption. Zinc, often with cadmium, is released into the environment during the use or breakdown of lubricating oils, vehicle tires, galvanized metals and fertilizers. The major sources of land pollution are the industries such as pulp and paper mills, sugar mills, oil refineries, power and heating plants, chemicals and fertilizer manufacturing units, iron and steel plants, plastic and rubber producing complexes and so on. Huge amounts of solid wastes are either dumped, burnt, or emptied into rivers and seas. Most industrial furnaces produce a gray, powdery residue of unburnt material known as fly ash. The fly ash, cinders, solid wastes and litter all are thrown away by industries and form huge mounds which spoil the landscape. Our households too contribute a large amount of solid rubbish in the form of domestic wastes. Some common examples are groceries, food scraps, vegetable remains, packing materials, cans, cardboard cartons, rags, paper, cinders, ash, broken gadgets, wood, worn-out furniture, metals, bones of dead animals, plastics, polythene bags, ceramics, glass, aluminium, rubber, leather, construction rubbish, brick, sand and other junk. Some man-made materials can be used again such as paper, scrap metal, glass, polythene, plastic, etc. But the majority of these cannot be reused and must be got rid of somehow. All these go to constitute heaps of municipal refuse. If not properly disposed, this rubbish can prove perilous, filthy and unhygienic. Such places often become a home for rats, flies, mosquitoes, bacteria and many other vectors, which may spread numerous human diseases. Minimizing land pollution. It should be necessary for the industries to install collectors to remove the particulate wastes, fly ash from the chimneys. Appropriate methods should be developed to dispose of or utilize the other types of pollutants. The garbage, instead of burning in the open, can be used not only to produce energy but also as filler for cement, bricks, asphalt and pavings. Some of these wastes, if properly sifted and separated, can even be recycled as raw material for other industries. Another simplest method is crude tipping or open dumping, a common method used in most Indian cities. More satisfactory is controlled tipping or the sanitary landfill, which is recently adopted in Delhi for solid waste disposal. The sanitary landfill is a better remedy for larger objects because it brings about inexpensive biodegradation of such trash without causing much pollution, disease and ugliness. In sanitary landfill, a layer of about 2 meters of refuse is covered by at least 23 centimeters of earth, ash or other inert material, up to the level of the hole chosen. The chosen holes may be low-lying watery areas and ditches. The land, thus, reclaimed can be used for making gardens, parks, playgrounds or apartment complexes. Before such filling, the wastes can be pulverized by machines to a uniform size. By this method the volume of refuse is reduced and some of the refuse is more quickly biodegraded. There are certain persons like Nek Chand who has found an aesthetic use of household refuse in the construction of world-famous monuments such as Rock Garden of Chandigarh. 4. Radioactive pollution. Radioactive isotopes, or radionuclides, are forms of elements with unstable atomic nuclei, that is, they decompose with ionizing radiation in the form of alpha or beta particles, or gamma rays. Many radioisotopes, such as radium-226, uranium-235 or 238, thorium-232, potassium-40, or carbon-14, occur naturally in rocks and soil. Other radioisotopes such as those of cesium, cobalt, iodine, krypton, plutonium, and strontium result primarily as fission products from atomic bomb fallout, nuclear reactors or other radiation sources. Of more than 450 radioactive isotopes which can occur as fission products, only a few are of major environmental concern. These are primarily argon-41, cobalt-60, cesium-137, iodine-131, krypton-85, strontium-90, tritium and plutonium-239. Bevington, 1973. Within biotic communities and ecosystems, these radioactive elements may become dispersed or accumulated, depending upon the biological activity of the element and period of radioactivity of the isotope. Strontium-90, for example, normally occurs in radioactive fallout, has a half-life of 28 years and behaves like calcium in biogeochemical cycles. Thus it is absorbed by plants, ingested by animals and deposited in bone tissues close to blood-forming tissue. Strontium-90 can also concentrate in natural biological systems in following method: water, bottom sediments, aquatic plants, freshwater clams, minnows and small fish, muskrats. It is demonstrated that due to this food chain muskrats concentrate strontium-90 3,500 times above the levels of the water in which they live. Grazing animals concentrate strontium-90 by ingesting it through grass and forage, and it can then be passed on to humans through milk. Radioactive phosphate, cesium and iodine-132 also can readily accumulate in plants and animals through natural food chains. However, in food chains involving arthropods, radioactive isotopes of potassium, sodium, and phosphorus accumulate, but isotopes of strontium and cobalt do not. Reichel et al. 1970. Although isotopes may accumulate in human tissues as well as those of plants and animals, it is not established at the present time whether current levels of isotopes in human tissues represent serious health hazards to man. Southwick, 1976, Smith, 1977. Some medical scientists such as Goffman and Tamplin 1970 and Sternglass 1972, however, feel that man's radiation exposure from artificial sources is already sufficient to produce serious disease problems, leukemia and bone tumors, genetic damage, and infant mortality. 5. Noise pollution. Noise is primarily a feature of cities and is defined as sound without value, or any noise that is undesired by the recipient. Noise levels in many urban industrialized situations are known to be deleterious to human health and efficiency, with effects on the sense organs, cardiovascular, glandular and nervous systems. High-intensity sound or noise pollution is caused by many machines man has invented during his technological advancement. Thus, there exists a long list of sources of noise pollution including different machines of numerous factories, industries and mills, different kind of auto and motor vehicles such as scooters, motorbikes, cars, tempos, buses, trucks, tractors, aircrafts, motorboats, ships, loudspeakers, social gatherings, loud pop music, supersonic hourcrafts, etc. Noise can be measured by a sound meter and is expressed in a unit called the decibel dB. The quietest sound that the human ear can detect, 0 decibels, is called the threshold of hearing. Calcutta, Bombay and Delhi are regarded to be noisiest cities in the world, where the average noise level was 90 decibels in 1975. Noise pollution has certain well-evident ecological and pathological effects on biota and human beings. For instance, the sonic boom path associated with SST projects such as Concorde produces noise of a very different order, in the form of sudden but repeated shock waves, which is suspected to cause disturbance to wild birds as well as domestic stock in buildings. See Simmons, 1974. Noise is not only annoying but if continued for a long time can also result in emotional and behavioral alterations in man. Health hazards of noise pollution. Noise causes disturbances in the atmosphere which in turn interferes with the systems of communication. It affects our peace of mind, health and behavior. It affects our peace of mind, health and behavior. Sudden loud note can cause acute damage to the eardrum and the tiny hair cells in the internal ear, whereas prolonged noise results in temporary loss of hearing or even permanent impairment. It causes headache, irritability, and airs focusing. Noise is known to flush the skin, constrict stomach muscles and produce ulcers, heart disease, high blood pressure, nervousness and other defects in sensory and nervous systems. Reducing noise pollution. Though it is almost difficult to completely get rid of the malady of noise pollution of current electronic age. However, there are certain methods by which deleterious influences of noise pollution can be minimized and intensity of noise level can be curbed. The means of noise control are: A. To manipulate the source so as to reduce the noise at its origin, B. To interrupt the path of transmission, and C. To protect the recipient. Legislation and public awareness are essential. Nobody should be permitted to create noise in silent zones or during night. Noise-producing traffic vehicles should be prevented from plying on the roads and their use of pressure horns should be entirely checked. Standards for noise control measures should be set up for industry and community, and a comprehensive safety program enforced. The path of the sound can be interrupted by using various materials which absorb the sound energy. Horticulturists should suggest adequate varieties of vegetation which can be planted around factories, hospitals, educational institutions, public libraries and houses which may reduce sound pollution and also may minimize dust pollution. Acoustic materials and mufflers can also be used to protect oneself. Under noisy situations, one may hold his hands over his ears or may run away from the source, or may simply stuff a bit of cotton or earplugs in the ears to reduce much hazards of noise pollution. VYAY08ORUN. Ecology and human welfare. Natural resource ecology. Natural resources. Conservation and management. Other nature is quite generous. For thousands of years, it has provided us with all of our basic needs. IR, water, sunlight, food, clothing and shelter. Up to the beginning of 20th century our thinking was that our natural treasures were eternal and virtually inexhaustible. However, by observing the present trend of ever-increasing human population and mindless exploitation of these repositories, we can speculate for future that mankind seems to be heading for a grim time which might be full of shortages, scarcities and chaos. The fortune which the mankind had inherited from the nature, has been and is being exhausted so carelessly that it is not likely to last for very long, if not harnessed properly. CIASSIFICATION of NATURALRESO. We may classify resources into two major types according to how they are affected by their consumers. 1. Non-renewable resources. These resources once gone, have very little chance of recovery or resynthesis. Non. These wind pumps use the power of the wind as their source of energy. Renewable resources are not altered by use. For example, space once occupied becomes unavailable, IDIS, replenished, only when the consumer, user of a commodity leaves. Mineral deposits are formed slowly over millions of years and once used cannot be regenerated, e.g., fossil fuels, such as petrol and coal. Since the formation of soil takes thousands of years and is not renewable in the lifespan of many generations, it is thought of as a non-renewable resource. 2. Renewable resources. These resources are constantly regenerated or renewed. Birds in a population of prey continually supply food items for predators. Plants, crops, forests, etc. An animal's milk and meat production form another good example of renewable resources, since their continued harvest is possible upon proper planning and management. Other examples of renewable resources are wildlife, aquatic life, pastures and forests. Conservation of natural resources. Conservation has been defined as the management for the benefit of life including humankind of the biosphere so that it may yield sustainable benefit to the present generation while maintaining its potential to meet the needs and aspirations of the future generations. Thus, conservation is one of the most significant applications of ecology. It avoids unplanned development which breaks ecological as well as human laws. A conservationist has twofold basic aims: I, to ensure the preservation of a quality environment that considers aesthetic and recreational as well as product needs, and E, to ensure a continuous yield of useful plants, animals, and materials by establishing a balanced cycle of harvest and renewal. Odom, 1971. Thus, conservation process remains chiefly concerned with use, preservation and proper management of the natural resources of the earth and their protection from the destructive influences, misuse, decay, fire, or waste. In fact, the preservation of rare species is certainly not all that conservation means. Conservation is never a hoarding, or even rationed use of a limited source but a constant effort to increase the resources and rapid resynthesis of the materials. Thus, conservation of living resources has following three objectives: 1. To maintain essential ecological processes and life support system, 2. To preserve biological diversity, and 3. To ensure that any utilization of species and ecosystems is sustainable. Conservation, therefore, makes significant contributions to social and economic development. Different kinds of natural resources and their conservation and management practices can be studied under following heads. 1. Minerais and their conservation. Minerals are often called stock or non-renewable resources because their new materials can only be extracted from the Earth's crust once. But even in the transformed state in which they are used, they are not lost to the planet and so are ideally available for reuse. Terrestrial mineral resources. For his industrial, technological and cultural growth, man has required and still needs a great variety of inorganic materials, all of which come from the Earth's crust. Chief among these are the ores which are used on a large scale to yield metals such as iron, aluminium, copper, silver, gold, platinum, etc. To them must be added elements which may not be needed in large quantities but which are indispensable in many modern industrial processes, as for example catalysts and hardeners such as vanadium, tungsten, and molybdenum. Finally, there are non-metallic materials which are vital to industrialized nations such as sand and gravel, cement, fluxes, clay, salt, sulfur, phosphorus, diamonds, and the chemical byproducts of petroleum refining. B. Marine mineral resources. The mineral resources of seas can be divided into three categories: those which are dissolved in water itself, sediments present on the seabed at various depths, and those present at some depth below the seafloor, beyond the sediments of relatively recent origin. At present, the utility of the dissolved elements is in the direct proportion to their abundance and to the relative cost from terrestrial sources. Cloud 1969 has enlisted commonest elements, e.g., strontium, boron, silicon, fluorine, argon, nitrogen, lithium, rubidium, phosphorus, etc. in seawater which could be extracted. Common salt is one of the resources that has been utilized since prehistoric times for its value in flavoring and meat preservation. At present, only salt, magnesium, and bromine are being extracted in commercial quantities, and sea seems to remain inexhaustible for these elements. Except a few other elements, economically feasible recovery processes of most other elements from sea is very low. Sediments and sedimentary rocks on the continental shelves are sources of certain materials. Placer deposits equals materials that has been concentrated in a particular place by mechanical action contain workable quantities of gold, tin, and diamonds, and the other sediments which may be liable to exploitation include sand, gravel, and shells. However, land use problems by their extraction from the land would largely be prevented by the use of the sea as a source, provided that the ecosystems of the oceans were not too greatly damaged by the recovery processes, which create great quantities of silt and also eventuate imbalance in the sedimentary systems of the seafloor. Phosphates are found as nodules and in crust. A further resource of the continental shelves is freshwater. Large quantities of artesian water may be found in certain aquifers. Finally, there are petroleum and natural gas. The deep sea basins is found to contain enormous quantities of minerals such as manganese, nickel, cobalt, and copper, but their extraction is not economically feasible. Cloud, 1969. C. Conservation of terrestrial mineral resources. Until recently, little attention was paid to conservation of terrestrial mineral resources because it was assumed that there were plenty for centuries to come and that nothing could be done to save them anyway. But recently, Cloud 1969 made it evident that both assumptions are dead wrong. During his assessment of the situation, he has formulated following two situations about the exploitation of terrestrial mineral resources. 1. The first is the demographic quotient, or Q. Total resources available. Q equals population density x per capita consumption. As this quotient goes down, so does the quality of modern life. It is going down at a frightening rate because available supplies can only go down as consumption goes up. 2. The other concept introduced by Cloud is the graphic model of depletion curve, as shown in figure 15.1. With the present procedure of mine, use and throw away, a huge boom and bust is projected, as shown in curve. The time scale is uncertain because lack of data, but the bust could begin within this century since certain key metals and fuels such as zinc, tin, lead, copper, uranium, 235, natural gas could be mined or extracted out within 20 years insofar as the readily exploitable reserves are concerned. If a program of mineral conservation, substitutions using less scarce minerals wherever possible, and partial recycle were to be started now, the depletion curve could be flattened as shown in curve B. FSI recycling combined with stringent conservation and air reduction in per capita use could prolong depletion for a long time. As shown in curve C, it should be noted that even with prefect recycle, depletion would still occur, because small amounts of most metals lose by friction, rust, etc. Consequently, terrestrial mineral conservationists have suggested following measures for terrestrial mineral conservation. 1. Technological advancement for extraction of minerals from sea, which is unlimited supply depot. 2. Extraction of metals from lean ores with the use of vast quantities of cheap atomic energy. Granite is suggested as a source for the extraction of many metals. 3. Recovery of mineral elements from scrap and waste recycling. Ecological aspects of mining. Most kinds of mining processes of man have side effects of an ecological nature. Underground mining may include whole new towns among its surface installations, e.g., the Kateri Copper Project, Junjunu, Rajasthan, India. Timber is cut in forested areas, often leading to soil erosion and the tailings in mine. PRODU Court ION. MINERAL. Present 1. Figure 15.1. Alternate depletion patterns for mineral resources. A. Pattern of rapid extraction and depletion of minerals that will occur under the present custom of unrestricted mining, use, and throw away. B. Depletion time can be extended by partial recycle and less wasteful use. C. Efficient recycle, combined with stringent conservation and substitutions can extend mineral depletion curves indefinitely. Cloud, 1969. Waste have to be discarded. Large-size solid wastes can be used as backfill or sold for aggregates, but tailings usually yield silt particles to wind and water and are often chemically unstable. The only suitable treatment appears to be to fix them with vegetation. Mine waters are often heavily contaminated and have to be treated chemically and physically, or injected into safe rock strata. Further, in most countries open pit mining is more widespread than extraction by shaft. In such mining, waste disposal becomes a major problem to which backfill is the obvious solution. If the topsoil is saved, then restoration of agriculture or recreational use is often possible. The processes of concentration, beneficiation and refining may all create biological changes if various products are released into nearby ecosystems, i.e., they may create environmental pollution which affect adversely the ecosystems. 2. Energy and its conservation. Energy utilization has become the modern key to human progress. At the present time, modern nations differ markedly in their energy consumption, with industrialized nations such as European nations like Britain, Germany, Poland, etc., United States, Japan, Hong Kong and Singapore, typically using 10 to 50 times as much energy per capita as agricultural and developing nations such as India, Bangladesh, Indonesia and Ethiopia. Southwick, 1976. Higher energy consumption is often associated with higher gross national product and personal income per capita, but it is also associated with higher levels of industrial pollution. Fossil fuels such as oil, gas and coal form the non-renewable sources of energy and account for 90% of the world's production of commercial energy. Hydroelectric and nuclear power accounting for only 10%. The figures are: oil E 39.5% energy. Natural gas, circa, CCCOE Iranini 19.6% energy. Coal, Urani 30.3% energy. Hydroelectric 6.7% energy. Nuclear 3.9% energy. Scent of its pollutants. This plant has also been used as a new source of food.